f is constant means we need to show that u and v both are constant. Okay, we have fz equal to u plus iv analytic, so CR equations ux equal to vy and uy equal to minus vx we have. Now differentiating partially this expression with respect to x, so we have alpha ux plus beta vx is gamma. Gamma is constant. I repeat, alpha u plus beta v equals gamma. Alpha, beta, gamma all are not zero at a time. That is given. Now differentiating partially the given expression with respect to x, we have this. Again, differentiating partially the same expression, alpha u plus beta v equals gamma. Partially with respect to y, we have alpha uy plus beta vy is 0. Okay. Now we shall use CR equations here. So what we have is alpha ux plus vx. What is vx? Yes, minus beta uy. Right? Using CR equations. Okay. Then what is vy? Vy is ux. So this is beta ux and alpha uy. So this is what is uy is. Uy is yes. Yes. This is alpha ux and this is plus alpha uy. It is same. We are using here only CR equations. I am writing this term alpha uy and this is beta ux. I write vy is ux. Okay, this is clear to all of you. Now we shall multiply this by alpha and this by beta. So what we will be getting? Okay. This alpha uy is like that, and that I am writing. So this quantity will get cancelled. Minus alpha beta uy and plus alpha beta uy addition, they'll get cancelled, and we get here alpha square ux plus beta square ux is 0. Okay. Now here the question is, which quantity is 0? Let us assume that alpha square plus beta square is 0. If alpha square plus beta square is 0, then sum of the squares is 0, then each number is 0. Okay. Yes, alpha beta are real constants. Sum of the squares 0, so alpha beta 0, and the moment alpha beta becomes 0 from this given expression, alpha u plus beta v equal to gamma, the gamma becomes 0. Alpha u plus beta v equals gamma implies gamma is 0. So all the three are all the three constant becomes 0, and this is not possible. So alpha square plus beta square cannot be 0. So you must have ux is 0. You have ux is 0, and by repeating the same arguments using CR equations, we from these two expressions we can easily show that uy is 0. Okay. Multiply this by minus beta and alpha and just proceed. So ux is 0, uy is 0, so uxy is independent of both the variables x and y, so u is constant. U is constant. Now ux is 0, uy is 0, substitute in the this CR equations becomes vx is 0 and vy is 0. Ux is 0, uy is 0, that would lead you to vx is 0, vy is 0. That means v is constant. I repeat, ux is 0, uy equal to 0 we have obtained by the procedure substituting ux and uy 0 in the CR equations. We get vx 0, vy 0, so v is constant. This gives v is constant. V is constant, u is constant, our function fz is u plus iv. So if alpha u plus beta v is gamma, all the constant alpha, beta, gamma are not 0, then the function fz equal to u plus iv is constant. U and v are constants. Next slide. If fz is u plus iv, it is analytic function, and f dash z0 is not 0. I am going to mention what is z0. Let us read the statement, look at the slide. That then two curves uxy equals C1 and vxy equal to C2 are orthogonal, where z0 is the common point of uxy and vxy. Uxy equal to C1 and vxy equal to C2. I repeat, function fz equal to uxy plus I vxy is analytic in D. Then the curves uxy equal to C1 and vxy equal to C2 are orthogonal if f dash z0 is not 0, where z0 is a common point of both the curves, u equal to C1 and v equal to C2. Next slide. Where z0 I already mentioned. Let's see this example, how we shall, these two curves are orthogonal. Of course, both are rectangular hyperbola that we can see from the study of 12th and first year. But how the analytic functions and the property of analytic functions are used to show that these two curves are orthogonal. Yes, the function we have uxy, both the curves. We shall take uxy is this, x square minus y square. We simply say it is u, and this is given as 5, and vxy is xy. It is given as 6. Okay. Now we are going to take analytic function. So let us take these two curves are given, x square minus y square is 5, xy equal to 6. I take this is 2xy, so I must multiply here to, it becomes 12. Now our two curves uxy and vxy we have, uxy equal to C1, vxy equal to C2. Okay. Which function we can correspond with these two real valued functions u plus iv? I already have proceeded just in the beginning that w equals, please make it little close, w equals z square, that is x plus iy square, x square minus y square to I to xy. So we get our mapping, our function w is z square, fz is z square, that you can see, or you may take u plus iv, and this becomes x square minus y square plus I to xy, and it is nothing but x plus iy square, so it is z square. So fz is z square, and z square is analytic function. Beyond the scope of this talk, all the polynomials are entire function. Entire function means throughout the complex plane the function is analytic. Z square, z cube, z raised to 4, e raised to z, all are analytic function. Entire functions, and entire function is analytic. Fz equal to z square is analytic, its derivative is 2z. So it is analytic. Now what the statement says, two curves u equal to C1 and v equal to C2 are orthogonal if f dash z0 is not 0. Now what is z0? Z0 is the common point of both the curves. So we need to find the common point of these two curves, u, that is x square minus y square equals 5, and v, that is xy is 6. Now just by simple calculation and few steps will give you the common points. You can take y is 6 over x and then just proceed. Common points are 3, 2. See, what are the common points here? I am not going for the procedure how we have find, but that's a simple calculation, one can do it. Common points are 3, 2 and minus 3, minus 2. That can be verified here. 3 square is 9, 2 square is 4, so 9 minus 4 is 5, it is verified. 3 into 2 is 6, minus 3 and minus 3. So these are the common points. At these common points, f dash z should not be 0. And that, this is the statement of our discussion. Two level curves, two curves are orthogonal if f dash z0 is not 0. So you can clearly see that f dash z, this is z0, 3 plus 2i is 2 times 3 plus 2i, not 0. Okay. So similarly at minus 3, minus 2, not 0. So by the property of analytic function, given two curves are orthogonal, and their graphs can also be seen. Next. find the image of the lines y equal to x minus 1 and y equal to 2x under the mapping w is z square. Okay. So we already have mentioned that mapping w is z square. Yes, please. W equal to z square x plus iy square x square minus y square plus i2xy. So u is x square minus y square and v is 2xy, that everybody knows. Okay. We have to find the image of line y equals x minus 1 under the mapping w is z square. Okay. So we have these equations. U is x square. To find the image of y is x minus 1. To find the image of the line y equal to x minus 1 under the mapping w is z square, we have u is what? X square minus y square. So this is x minus 1 square. And v is, I write v here, v is 2xy, so it is 2x into x minus 1. This is 2x square minus 2x, v is, and u is x square will get cancelled, x square minus 2x plus 1. So it is x square minus x square gone, so this is 2x minus 1, yes, u is 2x minus 1. We can see u and v are parametric equations. Please take your view little close. U is 2x minus 1, v is 2x square minus 2x. X is parameter. X is parameter. And we have to eliminate x. We find the image of line y equal to x minus 1 in u and v. I think that part is done. Yes, by eliminating x from these two equations, the image of y equal to x minus 1 under the mapping w equal to z square is the parabola u square equal to 2v plus 1. Okay. Let's see by graph. This is y is x minus 1, so you put x is 0, then y is minus 1. So this is 0 minus 1. Put x is 1, y is 0, so it is 1, 0. This is x, this is y. Now this is our line y equals x minus 1. Okay. It is z plane. And this is w equals z square mapping. Its image is parabola. This is u and v. It is w plane. W is u plus iv. U square equal to 2v plus 1. So v, if u is 0, v is minus 1 by 2. So we have this point 0 minus 1 by 2 very clearly from this. And v is 0, then u square is 1. So we have value of u is minus 1 and 1. We get this parabola. So this is this parabola. The image of this line is the parabola. Our next line is what? Y is
2x.
2x. So again we just proceed this way. The image of the line y equal to 2x intersect here. This is y equals 2x. Its image is the ray. That the procedure is here. U x square minus y square, v is 2xy. Substitute to y is 2x, and here y is 2x. So you will have two equations. Okay, if you let me show you. This is already done. Okay, what will be u? U is x square minus 2x whole square. So u is minus 3x square. What is v? 4x square. So we need to eliminate this part. Substitute the value of this is u equals minus 3. What is x square? V upon 4. So this is 4u plus 3v equals 0. The image of 4u plus 3v is 0. Y equal to 2x. Image of y equal to 2x under the mapping w is z square is 4u plus 3v equals 0. But look at this. For any x, u is always negative, at most it is 0, and for any x, v is always positive. So it is a ray, but with the condition u is negative or at most 0, v is positive or 0. So that would be ray. That would be ray. So it is ray in which quadrant? U is negative, v is positive. So second quadrant. This is w is z square, that we all know. This is ray. This is the. So its image is ray. This is 4u plus 3v is 0. U is negative, v is positive. Okay, friends. So this, as far as this problem is concerned, find the image of the lines y equal to x minus 1 and y equal to 2x under the mapping w is z square. Let's see whether angle between these two curves is preserved or not. What is the angle between these two lines? Y equal to x minus 1 and y equal to 2x. For example, this angle is alpha. Then what is alpha is that we all know the formula. That is, yes, alpha is tan inverse m1 minus m2 upon 1 plus m1 m2. What is the slope of y equal to 2x? 2. Y equal to mx plus c. So its slope is 2. This is tan inverse 2. Then what is the slope of y equal to x minus 1 is 1.